Hello and welcome back. In our last video we did solve a simultaneous equation with three unknowns using the Cramer's rule. So today we want to use the Gaussian method to see how it will unfold. You're going to use the same example because whichever method you use, the values of a simultaneous equations are supposed to be the same. The method doesn't matter. So we had 3x plus 3y plus 2z is equals to 1, x plus 2y is equals to 4, and lastly our equation was 10y plus 3z is equals to -2. And in the Gaussian method or gaussian-Jordan or Gaussian elimination method, there are so many variations. We are simply row reducing. So we will organize our matrix, or our equations will be written in the form of a matrix. So we will have 3 1 0 3 2 10 2 0 3, and then on the other side we will have 1 4 -2. We are going to row reduce, and the aim of our row reduction is that on the left we are going to get an identity matrix which takes the form 1 0 0 0 1 0 0 0 1, and on the other side we're going to get our values, which will be the values of b1, b2 and b3. So that's our main target. Now we'll begin our row reduction, meaning you're supposed to get a 1 here, another 1. The leading diagonal will have values of 1. With that in mind, we can go ahead and row reduce. We will have a clean slate here, so let's write it. We're going to have 3 3 2, and then perform the several row operations till we get our desired value 0 10 3 -2. So our first step will be to make this value 1. So we are going to have a third of r1, and that operation remains on row 1. In our next line we will have 1 1 2 over 3 1 over 3. The rest remain unchanged. 1 2 0 4 0 10 3 -3. In our second operation we want a 0 here, so we can as well subtract row 1 and row 2. So row 1 minus row 2, that operation is on row 2. We are going to write 1 1 2 over 3. Only the second row is affected, so we will have 1 minus 1 gives us 0. 1 minus 2 gives us -1. 2 over 3 minus 0 gives us 2 over 3. 1 over 3 minus 4 gives us -11 over 3. And then lastly we have 0 10 3 -3. When you look at it quite well, we need a positive here, so we're going to say -r2, and that operation remains on row 2. Then you write it clearly here. We will have 1 1 2 over 3 1 over 3 0 1 -2 over 3 11 over 3. One thing you need to know is that when you're applying a row operation, it covers the whole row. There are no exceptions, and only the affected row changes. Everything else remains constant, -3. So you can see we are in the right track. We have a 1 here, we have a 1 here. So we are targeting a 1 at that far end. We will go ahead, and we also need a 0 at this point. Where we have 10, we need a 0. So we are going to say R3 minus 10 R2 to go to R3. Because if we use R1, we will get a 1 here. So you will be moving backwards, and yet you're moving forward. So that operation, you're multiplying row 2 by 10 and then subtracting it from row 3. Everything else remains constant, so we just copy everything else. We have 1 over 3. Then row 2 is not affected, so we copy it again. -2 over 3, 11 over 3. And now row 3, we will have 0 minus 0 is 0. We multiply this by 10, subtract from 10, we get a 0. 3 minus, we subtract 3 minus 20 over 3. That gives us 29 over 3. And now here we have -3 minus 110 over 3. That gives us 116 over 3. That gives us 116 over 3. So we will have 116 over 3, and it's a negative. So let's just write that again here. We have 1, 1, 2 over 3. We have 1 over 3, 0, 1, -2 over 3. Here we got 11 over 3. In the last row we get 0, 0, 29 over 3, then minus 116 over 3, and it's a negative value. So we'll go forward, we continue. We can simplify the last row by simply saying 3 multiplying by a reciprocal, because we want a 1 here. So definitely we multiply by a reciprocal. We are saying 3 over 29R, R3 goes to R3. If you multiply 116 over 3 by the reciprocal, it gives you -4. We have 1, 1, 2 over 3, and we have a 1 over 3 at this point. We are having 0, 1, -2 over 3, 11 over 3, 0, 0, 1. We have a -4 here. So the third row is already done. There's nothing you can do about it. The only thing you're left to do is put a 0 on the first row in the middle and a 0 here. So we have to eliminate those two. We have R1 plus R2. It will give us a 0 at that. Where we have 2 over 3, we will get a 0. At the same time, we can say row 2 plus positive 2 over 3, row 3 will help us eliminate the -2 over 3, because we're targeting to get a unit matrix, or a matrix whose diagonal entries are 1, and those are the only entries it has. We're going to get here 1, 2, 0, 1 over 3 plus 11 over 3 is 12 over 3, which gives us 4. And on this other side, we're going to get 0, 1, 0. 11 over 3 plus 8 over 3 gives us 3 over 3, plus negative 8 over 3 gives us 3 over 3, which is just a 1. And lastly, we had 0, 0, 1, 4, negative. And now we want a 0 here. We are going to have R1 minus 2R2, and that operation is left on row 1. Let's see what it gives us. We will have 1 minus 0, which is 1. We have 1 minus 0 is 1, 2 minus 2 is 0, 0 minus 0 is 0, 4 minus 2 is 2, then the rest 0, 1, 0, 1, 0, 0, 1, negative 4. So comfortably you can see that our value for x is 2, our value for y is 1, and our value for z is negative 4. You can watch our previous video on how to use the Cramer's rule in the description box. Thank you for joining us. Kindly like, share and subscribe. Bye.